Hi everyone, hope you're having a great day today. We're going to continue with learning about sequence and series, and we're going to talk about a specific type of sequence today called an arithmetic sequence. And 12.3 will be about a geometric sequence, and we're going to go over 12.4 and 12.5 as well, which is counting theories and binomials theorem. So we only have 4 more sessions before the end of the semester. So we're going to go over 12.2 and 12.3 today, 12.4, 12.5 when we come back from Thanksgiving. So, and then we'll take our 4th exam on the 4th, and you have until the 6th to finish. And our final exam will start on the 9th, and you have until that Sunday the 13th to finish it. Okay? All right, so let's get to it. So what is an arithmetic sequence? Well, we know a sequence is basically a progression of numbers, okay? But an arithmetic sequence where the difference between each and any 2 consecutive number or term is a fixed number called the common difference, or we use the letter D to denote the common difference. Okay, so the notation for this is the letter D. So basically the formula for D can be found by taking any 2 consecutive ones. So we can just take A2 minus A1 or AN minus AN minus 1. So take the current term minus the previous term to give us the common difference. Now remember that the common difference can be positive or negative. So we can either add or subtract in order to get to the next term. All right, so let's look at this example here. From one term to the next, so here we have our first term, which is 5. We're going to add 4 to get to the next value. So you can see here we're always adding 4, so therefore that common difference is constant, so it's a fixed number. So therefore we have ourselves an arithmetic sequence here. All right, for here, our first term is -9. So how do we get from here to here? We can just use a formula, which is A2 minus A1. So -7 minus a -9, which is 2. So if I add 2 each time, you can see that I'm getting the rest of my terms here. All right, here we have asked to find the first 5 terms of this arithmetic sequence. So they give us the first one, which is A1, and first term is 7, and the common difference is -3. So to get from one term to the next, all we have to do is add -3, or just simply subtract 3. And you can see here, we have the first 5 terms. We can rewrite this as AN is equals to 7, 4, 1, -2, -5, ... Okay, so this will give us our sequence. For the first 5 terms of this arithmetic sequence, again, they give us A1 is -12, D here is +5, so that means we're going to add 5 each times to get our first 5 terms. So nothing really difficult about this. All right, so here we come up with a formula to find out any term of an arithmetic sequence. So let's look at this here. We have AN equals to A1 plus N minus 1 times D. And you know A1 is our first term and D is our common difference. If I were to rewrite this, okay, remember that D here is just a number, okay? And N here is our variable. I can actually combine these two together. Now you're going to see later on when we actually put numbers in this is going to look something like the functions. So I'm going to compare that and let you see it here. Okay, here they ask us to find A13, so the 13th term, and AN, which is our general formula. So let's use what we know here. We know A1 is equals to -3. we know that D is equals to 4. So you can see here, if I keep adding 4, so D is equal to 4, and we plug it into the formula here. So I'm actually going to find AN first. So AN is equals to A1, which is negative 3, plus N minus 1 times D, which is 4. And I'm going to distribute and simplify this. You can see here, these two are just constant, so I can combine those two. That gives me 4n minus 7. So this looks very similar to the function f of x is equal to mx plus b. So what I want you to see here is that an arithmetic sequence is nothing more than a linear function. Okay? Let's look at the similarity here. So the n value here is basically the x value, because that's our variable. And the d value here is our m. So d in an arithmetic sequence is the same thing as m in a function. They mean the same thing, and both of them basically means slope. Okay? Now remember how we find the slope. y2 minus y1 over x2 minus x1. And I want you to get used to seeing sequence as a function. So anytime that you have a general term, n and an, this is nothing more than a point. This is like saying the same thing as x and f of x, right? But we're commonly use x and y. So f of x is nothing more than y. So you can think of this as the same thing. Now we don't have a specific name for a of n, we just call it an, but this is nothing more than x and y. So remember that later on when we try to find the slope of this sequence, okay? So I shouldn't really use the term slope because slope is reserved for a function, but they equal each other here. Remember that a sequence is basically a progression of numbers, so it's a bunch of points, not a line. Function is a line, okay? So if you want to find A13, after you have this formula, AN is equals to 4n minus 7, now you can plug in 13. So A13 equals to 4 times 13 minus 7, and that will give you 45. Okay, moving on. And here you see the same thing. This is a typo. This is supposed to be a positive 4n, not negative. Okay, so I'll give you a second to try this. All right, so let's look at the formula first. So I know the formula is an equals to a1 plus n minus 1 times d. So I need to know what is a1 and d. Well, they did not give us either one, but we can definitely find it pretty easily. So they tell us that a2 is 9 and a3 is 15. So remember that d is equals to the difference of any consecutive terms. So of course we can use a3 minus a2 here. They are two consecutive terms. So we take 15 minus 9, so we have 6. If I know it's 6, That means that from here to here, I added 6. Now, if I want to go backward this way, you just have to subtract 6, so we get 3. So here, 3 plus 6 give you 9, 9 plus 6 give you 15, so that means that my first term is 3. So once I have that, I can easily write out my formula for an, 3 plus n minus 1 times 6. Let's simplify this. So I have 6n minus 3. So that is my general term. Now they want us to find a of 18, so we're going to plug in 18 for n. Okay, and that should be 105. Okay. You have any question, Mai? Okay, so what happened when we have two terms that are far away, where we cannot just basically subtract like we did before, right? So remember what I told you before, that d is nothing more than the slope. Now think of it like this. So whenever they give you a of 8 is equal to negative 16, think of this as a point. Well, 8 here is basically your n value, and a8 is basically like your y value. So think of this as your x value, think of this as your y value. So if I give you 8, negative 16, and the other one 16 and negative 40. So think of that an x and a y here. So if I want to find the slope, you just have to take the difference of y divided by the difference of x. And that will give you the slope. And the slope is exactly the same thing as d. So we have 40 plus 16. So we have 24. Negative 60 minus 8, that's 8. So that means I have negative 3. Okay? So that means that my d is negative 3. Well, we just found our d value. Now what we need is to find a1. Now, how would you find a1 if you are given 2 points and the slope? Well, we can just use a point-slope formula, or similarly, we can use the slope-intercept formula, y equals mx plus b, right? Now, this is for the slope, but remember, we need to find the a1. Now, this one right here will not give you a1, so do not use this, okay? We need to use the formula that includes a1. So a1 plus n minus 1 times d. So we need to use this formula here that involves sequence. All right, so we have this value right here we can substitute in, and we already found d. So plug in everything you know, and then solve for a1. So I'm going to use an, and an here is a8, which equals to negative 16, equals a1 plus, n here is 8, minus 1 times d, which is negative 3. Now, the only variable we have here is a1, which I can solve for. So here we have 7 times negative 3. So that gives me negative 21. I can add 21 over. That gives me 5. So a1 is 5. Okay, and that's all we need, right? Find a1. Great. So now let's put everything together and also find an. So an is equals to a1 plus n minus 1 times d. Let's simplify. Minus 3n plus 3. So we have negative 3n plus 8. And that is my general term. Let's double check our work. And we have a1 is 5. All right, it asks us to find the formula for the nth term of the sequence graph below. What is the domain range of the sequence? Okay. So let's look here. The first value is 1. So here, that's my first term. So A1 is equals to 3.5. A2 is equals to 3.0. A3 equals to 2.5. So that's just these points right here. Okay. So it may be easier to list it in a straight line instead of vertically like this. So AN is equal to 3.5, 3.0, 2.5, and so forth. So we can definitely see the difference between each one of them. Okay, we are subtracting 0.5. Subtracting 0.5. So that's my D value. D is negative 0.5. I got my A1 is 3.5. Okay, and they want us to find the general term, which is AN. Well, use the formula. I'm just going to use fraction here. I may not have to do that, but let's see. Yeah, let's just stick with decimal. All right, combine like terms here. I'm going to have 4 minus 0.5n. Or if we want to rewrite this as a fraction, so we can kind of see what is our slope. Our slope here is negative 1/2, and we have a y-intercept at 4. So this is my general term. Now, what is the domain of this? Now, remember that the domain of any sequence is going to be only whole numbers. Okay, 1, 2, 3, all the way up to infinity. So that means my domain is all whole numbers. Okay, now we also use the term natural numbers. Okay, so this n right here means all the natural numbers. And what about the range? Well, the range we can go from negative infinity, because if we keep going, we're going to keep subtracting. Now, the range will have all of the number, basically whole numbers and half of the numbers. Okay, so we can say from negative infinity. Well, this is kind of hard to write out. We can just use a formula in order to write out, because here is increasing by a half each time. So let's see how they wanted it. Yeah, they just listed out. Yeah, okay, that's fine. Now I assume this continue, but I guess it stops here. So since it stops here, we don't want to use the whole thing. So here, I guess you can just list it all out. So the domain here is 1, 2, 3, all the way to 6. And the range here starts at 1, 1.5, all the way up to 3.5. Okay, this is not an infinite sequence. So this is just a finite sequence, so we can list them all out. Okay, there we go, negative 1/2 plus 4, and our domain range. All right, now we're going to talk about a series. So a series is nothing more than the sum of the first n term. Okay, so Sn is a series, means it is sum of first n terms. Okay, so let me show you how they derive at this formula. So let's say I want to find the sum of the first 100 number. Okay, so what we're going to do is we're going to write the sequence backward. So I'm going to write 100, 99, 98, 97, 2, and 1. And I'm going to add them together. Now you're going to see a pattern here. That each of the pairs here, this pair, so if you add them up, each one of them will always equals 101. Now that's great because what we can do is we take all of that and multiply by how many numbers there are. So there are 100 numbers from 1 to 100. So what we can do is we can take 100 multiply by 101. And that will give me the total of these two. So basically twice of the sequence that we want, twice the sum of the sequence. So therefore, we need to divide that by 2. Okay? So now let's look at the formula here. So S 100. So that means the sum of the first 100 terms, so from 1, 2, 3, all the way up to 100, is equals to 100, so that's 100 terms, divided by 2 because we're adding 2 of these together. Now, we are adding the first term and the last term together, right? So 1 plus 100. So that's the first term is A1 plus the last term is AN. So you can see the formula here, how they arrive at this formula. N is the number of terms that you're adding up, dividing it by 2 because we are adding both of those together. A1 is the first term, AN is the last term, just like we did here. 1 is the first term, 100 is the last term. And here they're trying to rewrite this in terms of AN. Okay, remember AN formula? A1 plus N minus 1 times D. So they're just using that substitution there. Okay, but I just suggest you memorize this one and not this one because it's I think it's a little bit too complicated, and you just have to memorize these two separately and you'll be fine. All right, so S12. We need to find out the sum of the first 12 terms. All right, so let's look at our formula again. So there are a few things we need. So in order to get to S12, well, we know that N is equals to 12. A1, we can find that because it's given right here. That's just the first term, -9. Now we need to find out what is AN equal to, and we don't have that, right? So we can find out what AN is equal to by using the formula A1 plus N minus 1 times D. And that means now we need to find out what is D equal to. Well, we can look at the sequence to determine that. So you can see here, all we have to do is add 4 to get from one term to the next. So my D here is 4. Plug in our formula to find AN. And we know what A1 is, -9, so let's plug that in. Simplify a little bit. All right, so there we have our AN. So now we can find out what is A12 equal to. So plug in 12, 48 minus 13. So we get 35. So our last term is 35. So now let's go back to the series formula and plug it in. So N here is 12 divided by 2. First term is -9. Last term is 35. Simplify 12 over 2 is 6. This here gives us 26. So it gives us 156, which we got right here. We good? How much more do we have here? Oh, almost done. It goes kind of fast when you don't ask questions, so. All right, use a formula for Sn to evaluate the sum of the first 60 positive integer. Well, I did the first 100 integer for you. So we know that it's 1, 2, 3, all the way to 60. So this is A1, A2, and this is A60. So pretty simple. So we have our formula here. You know, n is going to be 60, a1 is 1, a60 is 60. And so we just have to plug it in to a formula. So we have a1 is 1, an 60, plug in the formula, 1830. Oh, pretty easy. All right, so this one's a little bit harder here. Not that bad, but still a little bit harder, because we're not given everything. I'll give you a second to try it, and then we'll go over it. All right, let's see how we do this. The sum of the first 17 terms of an arithmetic sequence is 187. So let's write out what is given here. So we know that S17 is equals to 187. Here they give us A of 17 is negative 13. Now what we need to do is find A1 and D. All right, let's see what we have here. So let's look at the formula and see what we can fill in. So we know that Sn is equals to n divided by 2a1 plus an. Let's see if we can plug it in and fill in as much as we can. So we know the S of 17 is 187, so write in 187 here. And our n value is given here. So 17 divided by 2. A1 we do not know, and an we do know. An is negative 13. All right, so this is good because the only unknown value is a1, so that means we can solve for a1. So let's do that. So we can multiply by 2 and divide by 17 here. And then add 13 over. And we get A1. So let's plug that into our calculator and see what we get. And I got 35. So A1 is equals to 35. All right, so we got that part. Now we need to find out what D is. Well, the formula that involves D is our general form, AN. So now that we found A1, we can plug that in. A1 plus N minus 1 times D. So let's find out. Now, AN we actually have over here. So we have a point that will give us the value, right? So let's use A17. So that's just a point. So A17 is equals to negative 13. A1 is 35 plus N here is 17 minus 1 times D. So now we have an equation that we can solve for, and the only variable is D. So let's do it. 17 minus 1 is 16D. Let's bring this value over here, so minus 35. That gave us negative 48. Now we can divide both sides by 16, and D is negative 3. Okay. So let's see if we got it right. All right, we see here that A1 is 35. That's good. And let's double check. Our D is negative 3. Great. All right, so now let's look at summation notation. So let me go over all of these notation here before we start. This symbol here is the capital sigma. It's just a Greek letter. It means summation. It means we're going to add all of the values together. Okay. So if it starts at 1, so the value down here, we call that the index. Now this index can either be I, J, or K. So these 3 letters are the most commonly used. This one right here is the starting term. And the last number here is called the ending term. Okay. If your starting term is a 1, that means that, let me use an N up here. That means that you're going to have a series. So S of N is defined as starting a term at 1 and stops at N. So you're going to add N terms together, and that's the definition of a series. Now, if it doesn't start at 1, it is not a series. So right here, this would equals to S of 10 because it is the sum of the first 10 terms. Over here does not equals to S10 because it does not start at 1. This is only the sum of 8 terms. You would think it's 7, but it's not. It's actually 8 terms. If you count 3, 4, 5, 6, 7, 8, 9, 10. Okay, there's actually 2, 4, 6, 8 terms here that you're adding together, not 7 terms. Okay, so we're going to look at how to find out this sum by hand and by calculator. And of course, in here, this would be your AI. That's the general term. Okay, so let's look at what it means here. So all right, so if I were to write it all out, this means the sum of the first 10 terms. So if I were to do it by hand, I would plug in each one of them in here. So we have 4 times 1 plus 8. So that's our first term, A1. A2 would be 4 times 2 plus 8, all the way up to A10, 4 times 10 plus 8. All right. Now, we don't have to do this, but I'm just showing you here that we are adding all 10 terms together to find this sum. Now we have a formula for this, so we don't have to do this one by one. All we have to do is find out using the formula. So an is equals to n divided by 2, a1 plus an. So all we have to do is find a1, we have to find an, and what is n? Well, we know n here is 10 because it starts at 1, so we only have 10 terms. a1, plug in a1 right here. So we have 12. an, so plug in 10, which we have right here. So we have 48. Now we can plug it in to find out what is s of 10 equal to. So we have 10 divided by 2, 12 plus 48. That's 5, 60. That equals to 300. Okay, pretty easy. There we go, we have 300. Okay, I'll give you some time to do this one. And I'll show you how to use formula after. Okay, so let's see how we can use a formula in order to do this and not manually. Okay, so you may want to know, okay, so let me explain how we would do this normally, and I'll show you the downside of it. So what does this mean? So my starting term is 3. So that means I need to find A3, A4, A5, all the way up to A9 and then add them all together. Well, that's all fine, but what if I give you and I ask you to find, I don't know, K from 27 to, I don't know, 900? Are you going to sit there and add all of them up? Definitely not. We don't want that, right? So the beauty of using the formula is as follows. I told you before that, for example, S7 means the sum starts from 1 and go to 7. Okay? Now, if the sum starts somewhere else, for example, 3 to 7, this does not mean the sum of the first 7 terms. This means it's only from A3, A4, all the way up to A7. Okay? Well, here's the beauty of it. Let me show you how you can actually use the formula in order to solve something where it does not have to start at 1. Okay, so here's the formula for this. So let me show you an example. So let's say I have, I want to find out the following. I think this is what, example is 3 to 9. Okay. Okay, from 3 to 9. So this means A3, A4. I'm going to write it all out. All right. So we have 7 terms here. Okay. Now, what does S9 mean? S9 means I'm going to start at 1 and go to 9 of whatever the general term is. So A1 plus A2 plus A3 plus A4 plus all the way up to A9. So I want you to see the difference here. What is the difference between these two series? Well, only the first 2 terms, right? Now, can you represent the first 2 terms by using a series? Yes, you can. So this piece right here is equals to S2, which is K equals 1, 2, 2. Now let's put everything together in general term. All right. So let's say I want to find out K from A to B, where A is not 1. Okay, so let's start some arbitrary value where A is not 1. Because if K is equal to 1, then my S would just be S subscript B. So if I have this, that means that I can take K equals 1 to B. So this will give me every single term starting from 1 and go all the way up to B terms. Okay, and I'm going to subtract the first whatever terms I need. Okay, which means that I'm going to go from K equals 1 to A minus 1. So this right here will take care of the first few terms that I do not need. Okay? All right, so if we look at this example up here, the summation from K equals 3 to 9 is equals to the summation of k from 1 to 9 minus the summation of 1 to 2. All right, so how do we get these numbers here? Okay, so you can see here that this right here is equals to this, the first two terms, right? Whereas this right here is equals to the entire thing, 9 terms. I'm subtracting 2 terms, so what I get is the result is the 7 terms here. Notice I'm removing the 2 terms here. All right, now I can rewrite this right here. This right here is s of 9. This right here is s of 2. How did I get that? From the starting term and the ending term. Okay, so look at the formula that I had here. From A to B, this right here is s of B. This right here is s of A minus 1. So therefore, this right here is k equals A to B. All right, so you can actually use the formula for a series in order to find out what this is equal to without having to list out every single value. So let's do this problem without having to list out every single values like this. Okay? Okay, so let's look again how we can do this with just using the formula. So this is equals to s of 9 minus s of 2. So s of 9, so let's see what I need here. I need to know what is my a1, and I need to know what is my an. So my a1, I just have to plug in 1 into here. So 4 minus 3 times 1 gives me 1. So S9 is equals to 9 divided by 2, A1, which is 1, A9, so now you have to plug in 9 into here. 4 minus 3 times 9, that's negative 27. And I'm going to have negative 23. Okay, so let's find out what that is. Actually, I'm going to do that on the next line. All right, I'm going to find out what the value of this one is. So that's S9 right there, minus. So for S2, I need to find out what is A2 is equal to. Well, I already have what A1 was equal to, right? A1 was 1. Now A2 is equal to 4 minus 3 times 2. So 4 minus 6 or negative 2. So I have 2 over 1. A1 is 1. A2 is negative 2. So here I have 3. 3 times 2 is 6. So I have 6 here. And this is negative 22, negative 11. Negative 11 times 9, negative 99 minus 6. So I have negative 105. Let's see if we got that right. Did I subtract it wrong? Let's see. I have negative 98. Got negative 98. Let's see what I did. Oh, No, that's 3. That's right. That's weird. That's really weird. Did they? I seem to miss something. Did I mess up somewhere? I feel like this is an arithmetic. Oh, I'm sorry. Right here. Darn it. Right here. It's supposed to be n divided by 2a1 plus an. Yep, right here. Okay, so I missed the formula. It's going crazy. Okay. All right, so this is supposed to be divided by 2, and this is supposed to be add, right? Wait. Oh, it's negative 23, so plus negative 23. That's fine. This is plus negative 2. Okay. All right, so we have negative 22. So this is still negative 99. And over here, so this is 1. And here, this is negative 1. So negative 99 minus a negative 1. So we have negative 99 plus 1 is negative 98. Okay, life is good again. So negative 98. Okay, thought I was going crazy. Okay, so also you can use the calculator. Of course, after I show you all that work, it was like, why did you use the calculator in the first place? Well, you need to learn how it works. All right, so I'm going to show you how to enter this in here by using the calculator. So let me switch to the calculator. So if you're using ClassCalc, this will also show up there. I'll try to use ClassCalc and see if I can figure it out. All right, so here, if you have the TI-84, you press alpha window, and the summation is the second option. So press 2. Now here you need to type in the index. So here you can use any letters you want. For simplicity, I just use X because then I don't have to play with alpha. And here it starts at 3 and goes until 9. And then whatever index you use, you have to use the same index in here. So 4 minus 3x. So if you use k, this needs to be k. If this is I, you need to use I. And press enter. So negative 98. Okay. So let's see if I can figure out on ClassCalc how to do this. I'm trying to look here and I don't see that option, which is good because then I didn't want you to use the calculator anyway. Yay, good. So they don't have it. All right, so you're going to have to learn to do this by hand using the method I just showed you. Okay? All right, so no graphing calculator on the next test. You just use ClassCalc like we normally do, because I didn't really want you guys just to type this in to get the answer. So practice understanding this formula. Let me go back here. Right, so practice understanding this formula here. Okay, so if the starting value is not 1, it is not a series, but we can always use a series by using this here. Okay, so if it starts at A, this needs to be A minus 1, because you do not want to subtract the A term, because it's going to be included in this summation. So we do S of B, okay, the ending number, minus S of 1 less than your starting number. Okay? All right, that's it for today, and we'll go over the next chapter on Thursday. Have a good day. See you next time.